Look at the crisp texture of this moon, perfectly balanced against the sharp silhouette of the monument below. But if you've ever stepped outside with your camera, pointed it at a massive moon, and pressed the shutter, you probably ended up with a tiny, blurry, overexposed white dot surrounded by black. We have the perfect target coming up to finally fix this problem. In May of 2026, the night sky is delivering a rare blue micromoon. To capture it correctly, we are going to build a precise step-by-step methodology, from the gear and location scouting to the specific manual camera settings required to pull off a gallery-worthy silhouette shot. Getting a professional moon photo does not require an expensive telescope. It comes down entirely to understanding celestial timing and manually overriding your camera's automatic mechanics. Mark your calendar. The peak of this event occurs on Sunday, May 31st, 2026 at 4:45 a.m. Eastern Time. However, your best viewing window actually happens the night before, just after sunset on Saturday, May 30th. You'll hear this called a flower moon, the traditional name for the full moon in May. It also earns the blue moon title because it is the rare second full moon to occur within a single calendar month. This shows the mechanics of a micromoon. Traveling its elliptical orbit, the moon reaches apogee, the point furthest from Earth, roughly 251,000 miles away. Because of this extreme distance, it appears smaller. This makes compensating with the right lens focal length an absolute necessity. Before we touch the camera settings, you need a stable foundation to combat that physical distance and any resulting vibration. You must have a sturdy tripod and a remote shutter release or an intervalometer. Now let's look at the lens. Your focal length strictly dictates how large the moon will appear relative to your frame. Here we see how different lenses frame the target. A 35mm wide-angle lens gives you a tiny dot in a vast landscape, but push into the 200 to 600mm telephone range and you compress the background, creating a giant moon that dominates the composition. Understanding the physical distance of our target and choosing the exact focal length to compensate for it are the non-negotiable foundations before you step outside. Step 2 is the stage. Select a foreground subject that is physically elevated from the horizon, like a monument on a hill or a lone tree on a ridge. This allows you to shoot above low-level atmospheric haze and cloud cover. Next, map the interception. Use planning software like PhotoPills to plot exactly where your camera needs to be so your lens looks directly past your elevated subject and into the eastern sky where the moon will rise. Once you're out there, you'll quickly notice how difficult it is to align the moon with a stationary object. Because the Earth is rotating, the moon is a fast-moving target, rapidly creeping upward and diagonally across your frame. Because it moves so fast, your shooting location must have lateral space. You need physical room to move your tripod quickly left or right to make last-minute alignment corrections. Location scouting is the engineering of a precise geometric trap for a fast-moving celestial body. Step 3. The camera setup. Switch to manual mode. Turn off image stabilization. Lock your ISO at 100. Set aperture to f8 or f5.6. To prevent motion blur from the moon's ascent, you have a strict hard cap on your shutter speed. Never shoot slower than 1 second. When creating a silhouette, the focal strategy feels counterintuitive. You want to manually focus directly on your dark foreground subject. Leaving the moon slightly soft behind a razor-sharp silhouette creates a much stronger narrative image than a blurry foreground. If you are photographing a lunar eclipse, the strategy shifts. As the eclipse reaches contality, the available light drops drastically. To compensate, use spot metering. Open your aperture to maximum width and push ISO between 400 and 1600. This ensures your shutter speed stays fast enough to freeze action. You also need a manual white balance shift. Setting your temperature between 4300 and 5500 Kelvin accurately captures the atmospheric scattering that turns the lunar surface red. With those specialized settings locked in, your sensor can finally capture the exact texture and the rich, dark orange-red hues of the eclipse. To resolve bright lunar details against the pitch black of space, you must entirely override your camera's automatic assumptions with strict manual boundaries. This is the result of that preparation: a warm, golden-orange moon perfectly framed behind the crisp silhouette of an elevated stone structure. We achieved this by executing our core checklist: an elevated subject facing east, plenty of lateral space to move, manual foreground focus, and a shutter speed firmly under 1 second. Opportunities for this specific alignment are rare. After May 2026, the next monthly blue moon won't arrive until 2028, and a seasonal one won't appear until August of 2032. So check your local time zones for that May 30th to 31st window. Pack your tripod, dial in your focal length, and lock down your location now. Astrophotography transforms us from passive stargazers into active participants. We are using geometry and optics to capture the physical mechanics of the cosmos.